Hello. Now we are going to look at how we tell if points are on a circle, inside a circle, or outside of a circle. So to begin with, we're going to look at the meaning of our circle, and that's going to help us with answering these questions. So we know that a circle is a shape where we have the same distance from the center of the circle that I'm marking here out to any point that's on the circle. That's what makes something a circle. We have a center point, and everything that's actually on the circle is the same distance away from that center point. So we're going to use that fact to figure out where our points are relative to the circle. So if we take the equation of a circle, x squared plus y squared is equal to 25, I recognize that as being a circle centered at the origin. So its equation is in the form x squared plus y squared is equal to r squared. So that tells me it's a circle centered at the origin. So its center is at 0, 0. So I'm going to write in my coordinates of my center. And what I'm saying is that any point on our circle is going to be the same distance away from our center point. So if we want to test, is the point 4, 3 on our circle? Well, we have the diagram here, so we're going to have a quick look and see whether it is or not. We start at the origin, go in the door 4, up the stairs 3, and we can see that we do in fact end up on our circle. So we're expecting the answer in this case to be yes, 4, 3 is on our circle. So how are we going to show this algebraically? We are going to get the distance between 0, 0 and 4, 3, and if that's the same as the radius of our circle, then our point must be on our circle. And if the distance between the point and the center was smaller than the radius of the circle, then our point would be inside the circle. And if the distance was bigger, say if we were getting a point like out here, the distance from that point to the center would be bigger than the radius, so that would tell us that that point was outside of our circle. So let's do this for the point 4, 3. So we want to know, is 4, 3 on the circle? So we would need to find the distance between the points and check it against the radius. Well, that means we need to know the radius of the circle. So if we go back to the equation of our circle, we have x squared plus y squared is equal to 25. And we know x squared plus y squared for a circle that's centered at the origin, x squared plus y squared is equal to r squared. Well, that means that the radius squared must be equal to 25. So we take the square root of both sides to find the radius. And we get the radius must be equal to 5 units. So now we know what we're testing against. Is the distance between this point and the origin, or 0, 0, going to be 5 units? So we're looking for the distance between 2 points, the center and the point that we're testing if it's on the circle or not. So we use our distance between our points formula from our log tables. So we have x2 minus x1 to be squared plus y2 minus y1 to be squared. That's all under the square root. And we say what our points are. So I'm going to take my point 4, 3 as being my first point, x1, y1. I'm going to take 0, 0 as being my second point, x2, y2. So I write down my formula, write down my points, label my points, and now I can sub in and I test whether this distance ends up being 5 or not. So our distance is equal to, and we put everything in brackets as we're subbing in, so 0 minus 4 to be squared plus 0 in brackets minus 3 to be squared. And when we tidy that up, we get the square root of minus 4 to be squared plus the square root of 3 to be squared. And we have to be very careful that all of this is in brackets or it won't come out correctly on our calculators. If we put in minus 4 squared without brackets, we'd get minus 16 instead of plus 16, which would be wrong. We get 16 plus 9, so we get the square root of 25. So we get that the distance is 5. So we found that the distance between our point and our the distance between our point and the center was 5, and we found that the radius was 5. Well, that tells us that the point is on the circle. Now, if we're looking at a point being on the circle, there's one other approach that we could take, which is that if we know if we have the equation of anything, and we think that a point is on the curve, or in this case on the circle, it should solve that equation. If we put in this value for x and this value for y, 4, 3, if we say x is 4 and y is 3, and we sub that into that equation should work out. It should be true. So is 4 squared, our x value squared, plus 3 squared, our y value squared, equal to 25. That's 16 plus 9 is 25. 25 is equal to 25. Well, that's true. 25 is equal to 25. So that would tell us that the point is on the circle as well. But the more general method that tells us where a point is, whether it's on the circle or inside or outside the circle, is going to be to use our distance formula. But it's important that we think about the fact that if a point was on a curve, it should solve the equation of that curve, or the equation of that line. Now, is the point minus 2, 3 outside the circle? So we go to our point minus 2, 3, in the door minus 2, up the stairs 3. So that's that point there. And we can see that that point is not outside the circle. It's in fact inside the circle. So when we get the distance between the origin and our point, minus 2, 3, we should find that this distance is smaller than the radius. But let's check it algebraically. So we're going to use our distance formula in order to do that. So we write down our formula and sub in. x2 minus x1 to be squared plus y2 minus y1 to be squared. And we have our points minus 2, 3 and 0, 0. And when we sub everything in, we get the distance. We know that we're checking the distance against the radius of 5. We found that in our first part of our question. So we sub in, and we get minus 2 minus 0 to be squared plus 3, all in brackets, minus 0 to be squared. And we get the square root of minus 2 to be squared plus 3 to be squared. And we get 4 plus 9. So we get the square root of 13. And when we put that into our calculator, we find that we get 3.61. Now 3.61 approximately is less than 5, so our point is inside the circle. Minus 2, 3 is inside the circle. Now, is 5 minus 4 inside the circle? So we go to our point 5 minus 4. So from the origin, in the door 5, up the stairs or down the stairs minus 4. So we're going down minus 4. We can see that that point is actually outside of our circle. But we're going to test it algebraically exactly the same way. So we know the radius of our circle is 5. So we are going to test whether the distance ends up being bigger than or less than our radius of 5. So we write down our formula as before. From our log tables, always make sure to check this formula in the log tables because it's fairly long and complicated. And we write down our points. And 0, 0. So we're testing the distance between the point and the center of our circle. I'll call this x1 y1, and x2, y2. It doesn't make any difference which way around you go. So we go x2 is 0 minus x1 is 5 to be squared plus y2 is 0 minus y1 to be squared, and all of that's under our square root. We end up with the square root of minus 5 to be squared plus minus by minus is a plus 4 to be squared. All of this can go in the calculator. We get the square root of 25 plus 16, so we get the square root of 41, which when we put it into our calculator ends up being approximately 6.4. Now 6.4 is bigger than 5, it's bigger than our radius. Our radius is what we're comparing against, so that tells us that our 0.5 minus 4 is outside of our circle. So that's how we test where our points are, if they're on our circle or if they're inside or outside of our circle. And that is what we need for now.